Hello friends, this is the video regarding KA's challenge series for classifying mathematical problems. So in this challenge, you got the different mathematical problems and your main aim is to classify which topic that the particular mathematical problem belongs to. So this competition organized by KAUST Academy by Saudi Arabia. And evaluation metrics it uses F1 scores. So I have done two solutions I had which is like one is using VLM with between 2.5 32B, using that multi prompt with multiple prompts with single user input. But due to that high computational compute for running it on local machine, so I don't implement that solution for building my app, which I'm giving demonstration regarding that later. So yeah, this is the solution regarding first solution, which gave me a high score of 83%. You can see I uses multiple prompts and single user input for classifying it, which topic that particular input text belongs to. Okay. So yeah, this solution gave me accuracy of around 83.28%. For more understanding, you can refer to my blog. I attached to my above link. You can check it out. Check it there. Now this is the low latencies and less computational expensive approach which I used here. And also I created a small demo app using FastAPI and Streamlit to give you an understanding how it's working. Okay. So yeah, in this like approach, you generally try to convert that input prompt or input text into that vector using BG embedding, and then uses this simple balanced deep model for that classifying it on which whatever the particular topics which are mathematical topics which are given to it. So it classified which topic that protects it belongs to. Okay, so let's just dive into the code to understand the implementation how I done that. So yeah, this is my backend code. Here I'm using FastAPI, and here I'm basically using middleware because to like give the permissions and all this credential, we don't have to worry. That's why I put it this identic for data validation part, and this is for describing the type of that data during time of validation. Yeah. So here I'm reporting some load model function and this thing from inference. Just go there. So here you can see I describe the model path. I basically describe the model architecture and basically loading the weights according to that and run it on real mode and then return it. In prediction, it's simple. It checks the list and then convert it to NumPy array, then shift it to the device, and then we basically now run the prediction process and return. Okay. Then we call the main predict function where we basically calling this predict function on that, and all the loading process are done with this main predict function. Let's go to the main model file where I describe the entire model. This is the model which I described earlier in my code. Okay. Here I'm using the embedding function where I describe it by BG large, which I'm using. Of course, I'm using batch inference for faster generation of the embeddings. Okay. Okay. Now let's go to the front end part, back end. So yeah, these were the things which I'm importing. JSON response is just to identify either the request is successful or not. Here I'm describing fast API that started is NLP inferencing, and I'm giving the description regarding that automatically generate the embeddings and whatever things it will be performing. And middleware for all the type of requests it will accept, which are provided by the front end. Here I'm describing seven types of mathematical labels, topics, which are given to us on the dataset. And yeah, here are the devices either to on CPU or GPU, whatever the available. Here we are loading the model. Here we are describing the pedantic for describing the whatever the things are there, like text should be in list of string format should be there. Prediction should be of list of strings, and same for the embeddings list of list of float values. If the values are not like this, it will throws the error because it does data validation part. Here you are basically giving the post request or reprocessing whatever the input you will receive from the front end. And then you perform this embeddings, generate the embeddings using the embed function. Then we from the predict function get the generated prediction, and then we are converting the prediction to string format according to the label mapping which we described in the above. Okay. Now here, if the response is successful, it return the code 200 on the backend and give it as prediction and embeddings. Okay. Now go to front end. Here we have created a simple Streamlit app describing the text classification embeddings, and here we're trying the header and setting its height and areas. Then here we're describing submit button, need strip extra values and going workspaces. Here we're describing the post request because it's local machine, so I will describe that local host 800 process and put text is given here. Here we are describing the subheader as a particular mathematical topic, whatever the topic would be. And here it write the top prediction, whatever the prediction will be there after mapping. And we are sort of describing the embedding vectors here. If not work, so it will throw you error or it will say enter some text. Okay. So here I am running it on backend. You can see that just let it now. So I'm calling UV because it's asynchronously working. So UV is used for that. And app here we are passing because app.py referring to the backend file and app reload. It's on 8000 port we are running it. So it started. Now Streamlit is running. You generally call the Streamlit run frontend.py. It's running in this port, localhost. Okay. So here it is running. Here I am passing just a basic input text. You can pass another also for testing. Here's are the input text. Let me mm, pass this term question. So wait, this is my input. What is the total area of the right figure and right root part together? It's quite a bit empty. Let's add this thing also. Let's do the submit. Started running. Now it says that it belongs to geometry and trigonometry, which is kind of correct because here we are basically trying to identify the area and right figure, which is generally referred to the geometry. Getting understand. Of course, this model performed good because it's giving 80% of accuracy. And yeah, this was the complete my complete project regarding classifying the mathematical problems into mathematical topics. So yeah, using FastAPI and Streamlit. Okay, that's all. Thanks.